So the pressure of the vapor of this pure liquid. So instead of this xb, can I directly substitute this over here? So there are 4 options which are given to me. Let's solve this question and let's try to understand what they are trying to say. So hello student, how are you all? I welcome you all to Learn Overseas. So as you know, we are doing 45 days challenge. In this, we are going to cover 45 topics in our 45 days. And over here, you can see the distribution of your topics according to physics, chemistry, and maths. And today, we are going to do one of the topic for your chemistry. And this is very beneficial for all of those students who are preparing for their JEE exam. So without any delay, let's start with our topic. As over here, you can say today, we are going to do Raoult's law of your solution chapter. So without any delay, let's jump to our topic. So Raoult's law. What is actually Raoult's law? To understand this, there are few basic things which you should know, which is vapor pressure of liquid solution. So let's say there is one container which is given to you over here. Yes, this is one container and this has a solvent A. Like this is your liquid over here. You can see this is your liquid which is present. Now due to this liquid, because this is your volatile liquid, so there will be some vapor which will be produced and those vapor are going to produce some vapor pressure. Let's say that pressure is PA naught. Why not? Naught over here signifies like this is the pressure of your pure liquid A. Now let's say there is one more container and this has your solute B, and over here also like how over here it was PA naught, over here this will be PB naught. So the pressure of the vapor of this pure liquid. So that's why over here I will write PB naught. Now when I mix this two liquid and I get I transfer them to this new container, over here both the liquids are there. Both of this liquid are going to produce their vapor and those vapor are going to extract some pressure, and that vapor pressure, there will be total pressure of this solution also you can say. So this is the solution of your both A as well as B. So over here the pressure of the solution we can write as the total pressure also, or we can write PS, which is the pressure of the solution, which will be the pressure of your A as well as your B. That's how I will write PS is equal to PA PB. Over here PA naught signifies the pressure of your pure liquid A, whereas this is the mixture of A and B. That's why we are writing the pressure over here, vapor pressure is equal to PA plus PB. Now, what is your Raoult's law? Let's see that also. So, let's understand this statement. You will understand. So, for a solution of a volatile liquid, this is an important point over here. Many questions, many times were easily solved if you know this point, which is your volatile. Volatile means this type of the liquid can be converted into the vapor at a given temperature. So, in this solution, we are using your volatile liquid. The partial vapor pressure of each component of the solution is product of its pure state. So let's say this is your PA. You can say partial pressure, partial vapor pressure of your A plus partial vapor pressure of your B. But this is a vapor pressure of pure component of your A. That's what written, of its pure state vapor pressure and its mole fraction present in the solution. So to understand this, what they are trying to say, this is nothing but your Raoult's law. Mathematically what they are trying to say, that your PA, which is given over here, PA and PB, this PA over here is equal to your PA naught multiplied by mole fraction of your A. So in short, I can write my PA is equal to XA times PA naught. That's what written over here. The partial vapor pressure of the each component. Let's assume component A. So component of A of the solution is product of its pure state and its mole fraction present in the solution. So it means that we can also write PB also. Yes, PB will be equal to XB PB naught, where this part which we understood in detail. So now if we keep this point in mind and we already know what is your PS, this was your Raoult's law, we can get to one more point, which is if we keep this point in mind and I just told you what is your PS. PS is your total pressure, total vapor pressure. So I can write PT is equal to PS is equal to PA plus PB. I can directly substitute this 2 over here. Yes. So if I'm going to substitute this, this will start to look something like this. Yes or no? XA PA naught plus XB PB naught. Over here, if you see what is your XA and XB, they are the mole fraction of the solution. Like if I say your XA is 0.6, then can you tell me what is your XB if only these two components are present in your container? You can easily say, sir, if this is 0.6, then this will be 0.4. How? Because we know that your XA plus XB is actually equal to 1. So if I know one component, I can write the another component. So based on this, can I write my XB can also be written as 1 minus XA? Why I am saying this? Because over here you can see there is XA as well as XB. So instead of this XB, can I directly substitute this over here? Yes. So over here if I substitute this, this will start to look something like this. And over here, when I will multiply this and I will open this bracket over here. So over here, what is going to happen? Let's see that part. Everyone understood this part. Now if we will see the next part over here, like the solution part of this, what's the next thing that I can write? I can write this is actually equal to, this statement is actually equal to XA, or this equation is actually equal to XA PA naught plus, because this is plus, I can write PB naught, and there is a negative sign. So I will write minus XA, and this is your PB naught. Why I am saying this? Because over here if you will see, now I got PA naught and this part over here. So there are two, like there is XA over here also, XA over here also. Can I take this as common? Yes. If I will take XA as common, so there will be PA naught minus PB naught, and this part will be left with me. And now this is a very important thing. Like this is a very interesting thing. Once we get to this equation, no, we can actually plot the graph of this. How? Let's see that part. Like if this is there, we understood how actually we got this equation. So if let's say this is your like y-axis, this is the part of your y-axis. Now obviously this is your x and this is your, like I can assume this is my slope. So I can write this is my x, this is my m, and this is my c. So you can see y is equal to mx plus c. So we can, like if we can say this, so we can just plot its graph. So let's see what is your x-axis, what is your y-axis. So if this is your x-axis, what actually I can plot on your x-axis? I can plot the what we can say mole fraction over here. Yes. So this is your mole fraction. On your y-axis, I can plot my vapor pressure. So this is your vapor pressure. And over here, if you will see, I am going to plot like PA as well as PB. So let's draw two parts of this, like your y-axis. So over here, why I am saying this? Because we can also assume a condition where your mole fraction of your A is actually 1, or you can say in the solution, there is only the mole fraction of your A, B is not there. Like in this situation, I can assume like the mole fraction of your A is 1, but the mole fraction of B in that situation will be 0. Like if this is 1, so I can say mole fraction of B for this situation will be 0. And if this is true, can I directly plot its point over here, somewhere over here, like because in this situation, because mole fraction is 1, so over here, whatever point I'm going to get, it will be my PA over here. Yes or no? Because over here we just saw how actually we are going to get this 2 point. Yes, we already know this part also. So over here, if I assume this is my 1, if this is my 1, so I can say my PA is equal to PA naught directly. Whatever the partial pressure I have, like partial vapor pressure for your pure liquid, that will be the same for your PA in this situation when my XA is equal to 1. So that's why I can directly plot this part over here. Just see, this is part A. So I can directly write this over here. Somewhere over here, PA naught. Now if this is true, so in this situation also I can take something which is like if over here x is equal to 1. So over here I can take my x is equal to 0. If my x is equal to 0 over here, so it means my xb will be equal to 1 in this situation. So over here I'm going to plot a point like PB naught over here. So I'm going to get this. And over here you can see this is at the lower end and this is at the higher end. I'm drawing like this. So over here, why I'm doing this? Because I'm assuming that like this graph assume that A to be more volatile. Like over here I'm assuming that my A is more volatile. That's why it is having more vapor pressure as compared to my B. So if I am going to plot the graph for this part, I can easily plot something like this. So over here, I can say this is the 1 point and this is the another point over here. So this was the part when I was drawing this. So what will be my PS? Like this will be the graph for my PS, or you can say PT also, which is nothing but pressure of your A plus pressure of your B. Yes, P total is equal to PS is equal to PA plus PB. Now I can draw two more lines. How actually I can draw two more lines? Because I already know this part, which is this. Just see over here, like I can easily write from here also, which is that, like whenever there is this situation over here, I can write my PA is actually, this is the first point which we have understood, which was like over here, this is there. So I can write PA naught multiply by XA. Yes, I can write PB is equal to PB naught multiply by XB. Yes or no? So in this situation, if I'm only considering this part, over here, just tell me what is going to happen. So over here, I'm considering that my XA is equal to 0 over here. So this whole PA pressure over here, like vapor pressure, will be 0. So the starting point for this will be over here. So as I'm moving in the mole fraction, like through the x-axis, my value of your XA is increasing. So if this value will increase, this PA will start to increase, yes or no? If this is increasing, that's why you can see the graph like this. Yes or no? This will be the graph for your PA is equal to PA naught XA, which I was telling over here. Now, in this situation, when it is your PB naught, the vapor pressure, what will be the pressure for your PB? For this situation, just tell me your XA, like XB is equal to 1, XA is equal to 0. So over here, there will be a maximum vapor pressure of your PB. Yes. So in this situation, like how the graph started from the 0 and ended over here, because over here it will be maximum. In similar way, at XB is equal to 1, so your PB will be maximum over here, and as we will go through, our XB will start to decrease. So if this is decreasing, this value will also decrease. That's why over here the graph will be something like this, and this will be for your PB is equal to PB naught XB. So this is the graph which you have to, like, you should know what's the idea and how actually we can draw this type of the graph. Once we know this part, like say, what's the use of this? So over here, we are given with certain, let's say, over here, I'm writing you this. This part is there. What do I mean by this? Can you see? It is cutting over here. So at certain mole fraction, where there is this mole fraction, I can see what will be the, like at this mole fraction, what will be the partial pressure of your liquid B, because this is your vapor pressure. So, or you can say the vapor pressure of your liquid B. So for this part, like if this is there, so this is for your like A, this is for your B. So over here I can say this will be for my A, this will be for my B at this given mole fraction, and what will be my total pressure over here, like P total. I can find this with this graph. That's why this was important to understand this. I think so everyone got the rough idea what is your Raoult's law. Let's do question based on this. So if this is the question which is asked to you, it is a little bit tedious question, but once you understand the question is very easy. Why? What is asked to us? Let's see. Two liquid A and B are mixed to form an ideal solution. No problem with that. The total vapor pressure of the solution. So you are given with your PS, because over here it is written as the total pressure. So what do we mean by total pressure? PT. PT means PS. This is given to me as 235 minus 135 x. Okay. But what is this x over here? Let's see. Then find the value of your PA naught and PB naught if x is the mole fraction of your B. So this is the mole fraction of your B over here. So to solve this question, once you get this question, this question is very, very easy. Why? Because what is given to us, this data is given to us, and they are telling us to find your PA naught. So let's assume that when only A is present, like I'm telling you, when only A is present in the solution, I'm assuming only A is present. If only A is present, then what is going to happen in that situation? Then your PS will be equal to only P naught A. Yes or no? Why, sir? Why only this? Because over here the mole fraction of A will be equal to 1, like if this is there, and mole fraction of B will be equal to 0. So like when I'm only considering A is present, in that situation PS will be equal to P not A, and if this is true, I can easily find the value from here. Why? From here I can write my P not A is equal to PS, which is given to me over here, which is 235 minus 135 XB. But when only A is present, will there be any mole fraction of your XB? No, it will be 0. So I can directly write this will be equal to 0. So I can write my P naught A will be equal to 235. This is the part 1. Sir, over here the unit is not given. Whatever the unit will be given to you, we will sort according to that. But because over here, like the unit of the pressure is not given to you, that's why we are just finding its value. Now in the second situation, like now it's very easy, because like in the one situation we consider only A is present. In the second situation we are going to consider only B is present. When only B is present. When only my B is present, in that situation, what is going to happen? Obviously, when only my like B is present, so over here I can write my PS will be equal to P naught B. Yes, I can write this part. And over here, if only B is present, so the mole fraction of the B will be equal to 1. Yes, and this is the value which we have to substitute over here. So I can write my P naught B will be equal to 235 minus 135 multiplied by 1. So your P naught B will be equal to directly 100. Like this, we can solve this type of the question also. Initially, if you will see, you will find a little bit hard to understand this question. Once you get the idea, like how actually we are going to solve this question is very easy. So now once we are done with this question, let's jump to our next question. And over here you will see, this is the JEE main question which have been asked to you. So what does this question say? Let's see that part first. So the question says the mass of non-volatile, non-electrolyte solute. What do we mean by non-volatile, non-electrolyte? It means this solute will not be converted, like there won't be any vapor which will be produced from this. And we are given with its molar mass 50 gram per mole, needed to be dissolved in 114 gram of octane to reduce its vapor pressure by 75%. So there are 4 options which are given to me. Let's solve this question and let's try to understand what they are trying to say. So let's write the basic data which are given to me. So over here, are we given with the molar mass of the octane? Yes. Like we are given with the mass, we can easily find the molar mass. How? Like because the name was given, that's why I was telling you its molar mass is given. Because for the octane, we can easily find its molar mass will be 114 gram per mole. So I can write molar mass of octane is 114 grams per mole, and mass of octane is given to me 114 gram. It means how many moles of octane are there? There is only 1 mole of octane which is there. Why? Mass upon molar mass, I will get 1 mole. Now next thing, are you given with the molar mass of your solute? Yes, we are also given with the molar mass of your solute. So I can write molar mass of solute is equal to 50 grams per mole. Yes. And what's the question? They want us to find the mass of non-volatile, non-electrolyte solute. So they want us to find the mass of solute. So this is our question over here. So if we want to solve this, how, like in which direction, and the mass of the solute. Over here your solute is non-volatile as well as non-electrolyte. This is important part. So if I want to find this, I can apply my Raoult's law. What, like the same formula which we just saw, it was PS. Yes, PS is equal to, over here there are 2, like you can say 2 liquids, or you can say 2 solute and solvent are there. I'm directly going to write my solute as S, and for octet I will write it as O. So I can write this as, for octet I can write partial vapor pressure of O naught multiplied by XO, like mole fraction of your octane plus partial vapor pressure of your solute naught and mole fraction of your solute. This is there. But over here, just tell me, because this is your non-volatile, will like it will be converted into its vapor pressure. There won't be any vapor pressure for this. So it means I can directly write my PS is actually equal to P naught O and mole fraction of O. And if this is true, I can write the next part, which is, sir, what is PS over here? If you will see the next line which is written, it is reduce its vapor pressure by 75%. So what is given over here? When the mass of your solute needed to be dissolved in 114 gram of the octane to reduce its vapor pressure by 75%. So let's say the vapor pressure was your PS. So this PS vapor pressure has been reduced to its 75%. So what is left? Only 25% of your like pressure of the octane is left. So I can write 20, like what is your total pressure in this situation? I will write total pressure is 25% of PO. I can directly write this PO naught if you want. PO naught, or let's assume it's PO naught only. So this will be PO naught X naught. So if this is true, what's the next line I can write over here? So what is 25% of PO naught? I can write this as 25 by 100. 25 by 100, which is nothing but 1 by 4. Yes or no? So I can write over here 1 by 4 PO naught is equal to PO naught. What's the mole fraction? Mole fraction means number of moles of octane upon number of moles of octane plus number of moles of solute. Yes or no? From here, I can solve it further. So if I'm going to solve this, what will be my answer? Over here, this part is like this is going to get cancelled. And over here, I can write this as 1 by 4 is equal to number of moles of octane. It was given mass upon molar mass, which is 114 upon 114, like over here, if you will see. So number of moles of octane will be equal to 114 upon 114, which is 1 mole. Yes or no? And number of moles of solute, which is given, let's assume the mass, like over here, let's assume this is your X. For your understanding, like I'm telling you, it is X. So over here, I can write what is the number of moles of your solute. It is a given mass, which is your X upon molar mass, which is your 50. So same thing I can directly substitute over here. So I can write 1 upon 1 plus X upon 15. So once you are going to solve this, what will be your answer? So I can multiply this 50 over here and 150 will be on the top. So what actually I can write over here, if I am going to multiply this, I can write this as 1 by 4 is equal to 1 by 4 is equal to 50 upon 50 plus X. If this is there, like I just transferred this, and from here I can easily solve the value of the X. Just try to solve this. I will bring this over here and this 4 will go over here. So this will become 200. So if this is your 200, so I can directly write 200 minus 50, where my answer will turn out to be 150. But what was this? 150 is what? 150 is the mass of your solute. So mass of your solute will be in grams. This is 150 grams. Let's check our option. Option A 50, option 2 is not correct. Option 3 is also not correct. Option 4 is correct. So the correct answer for this question is your option 4. So like this, we can solve the question based on your Raoult's law, and we have understood this. So that's all from my side. So stay tuned with us. So if you have any query or any doubt to us, you can ask it in the comment box. And if you want to watch the whole playlist, you can find it linked in the description box. So that's all from my side. So stay tuned with us. Thank you.